Hello. I'm starting up. Most people show up in the next 5-10 minutes. I could pause recording. Conversations probably was worth recording already. You know, Coffee Compiler Club, I say this every time. We get more or less people every meeting. It's Lisa, you're live on camera. Yeah, so I'm recording. Well, the meeting's about, you know, anything to do with language implementations. I don't have really very many restrictions at all. Mute yourself if you're not talking. Open mic. That's it. And then there's no set agenda. So whatever people want to talk about. Sometimes somebody has something. Sometimes I kick the ball off with something, but I don't. You know, last time we talked a whole lot about escape analysis, escape detection, bandwidth this, bandwidth that. Kirk, what is behind you?
Cute. Right. That's the pool at Georgie's, right?
Fine. Now I see it. Yeah, I didn't have enough zoom.
So normally on this day, we'd be sitting in front of that.
Yeah, I get it.
Right. But this year, unfortunately,
it didn't happen. Yeah. A lot of things didn't happen this year. Yeah, it sucked.
Yeah.
Yeah, it's all good.
C'est la vie.
So, I don't know. So, since I've called on you already, you want to throw out a war story? I'm looking for a conversation starter.
War story?
Yeah, sure.
I don't know. There's war stories abound, right? I guess. But
throw one out.
Actually, it's funny. I got a request this morning. Someone was like showing me all of these like execution profile stuff, and they said, "How do I reduce my memory footprint?" I don't know.
Okay. And what do you do with it? Yeah.
I don't know. It's like, you know, it's kind of like it's like a data mismatch from the from the question. It's like, you know, you expect me to get an answer from how? I'm gonna just, I guess, conjure it up, I guess. I have no idea.
Yeah, well, you see these questions all the time on the internet everywhere, you know, Stack Overflow and Quora. I have this giant ass program that does something funny, debug it.
Yeah, well, if you're gonna let me hijack the conversation like this, you know, we can have fun. The question is like, I'm not sure if we had this conversation before, but I always like to tweet people on profilers and sampling, because, you know, like everybody I think thinks that you need to, you know, like we're going to sample at 10 milliseconds, you know, or, you know.
Oh, we lost your sound. Crap. All right, I have nothing from Kirk right now except a frozen image. Yeah, right. Okay.
60 randomly taken samples.
Hey, Kirk, slow down. We lost you for about 30 seconds completely.
Did you?
Yeah, you screen froze and nothing happened.
Oh, okay. Okay, that was probably a good thing then. So no, I was just getting into the story about, you know, like how everyone thinks that you need like really fast sampling rates on profiling, and I was just thinking like, no, actually you don't.
It depends what you're doing.
Sorry?
It depends on what you're doing. You know, if you're doing large, long-running server apps and you're trying to diagnose stability, yeah, you probably don't need samples very often. If you're trying to do high frequency trading and you're tracking down your latency, your long tail, 99th percentile, you want, in some places, you want extremely high resolution profiling.
No, actually, I'm going to suggest that you actually don't need it, even in
Really?
HFT.
Okay, why?
Why? Because if you're sampling properly and you have a long latency, then most of your samples should be biased toward the long latency. And it doesn't matter what your sampling rate is, you just need to make sure that you don't have any other biases in your sampling techniques.
Okay, so I'm claiming long for an EFT would be measured in microseconds.
Doesn't matter.
But right, you're saying it's sampling has to be relative to what is a long pause that you're diagnosing.
No, actually not. It's like you have to look at it this way. Like if you spend, I don't know, like 20% of your time doing X and 80% of your time doing Y, then you expect whatever sampling you do at whatever rate you sample at, you should get like an 80% hit in the Y and a 20% hit in the X range. And that's independent of sampling.
Okay. I guess I was thinking
rates.
of you wouldn't actually catch any samples in your long distribution if you weren't sampling frequently enough. And your take is you're going to catch 20% in the one and 80% in the other independently. But if the rate is still too, we could both be correct. If the rate is low, you'll still get no samples out of your 80% will be none. 80% of 0 is 0.
80% of 0 is what
yeah.
you're talking about.
If I'm spending 80% of my time in a long latency stall and 20% doing math, and I am getting long latency stalls, once an hour during the trading day, and I'm sampling, once a minute.
That's not an 80% stall then.
Okay, fine.
That's not an 80% stall, and that's something that might matter, but it actually doesn't, in the overall scheme of things, that's not an 80% stall.
Yeah, you're right. Yeah, you're right. Yeah,
that's like if I have a slightly long stall over an hour, like that, you average that out, that's just not an 80% stall.
Right. Okay. So the difference is simply that the long latency transaction costs a hell of a lot more, and that's why they care so much. All the transactions with low latency, they make or win or lose some tiny percentage, and the long latency ones they lose big on. And so they're always tracking down the long latency stalls, which are a small fraction of the total time, but a high cost value. And that's just a different, that's their metric. The 99th% outlier costs you, as opposed to Amazon, where the 99th% outlier doesn't cost you very much.
Well, like a 99% outlier.
I mean, by 99, the 99th percentile outlier in, say, latency on the web page, not it's 99% longer. It's just whoever hit the 99th percentile in latency cost you a sale, as opposed to an EFT where it cost you the entire value of the transaction, as opposed to the delta increment you're making your profit on.
Well, it's like in a first past the post, yeah, the 99% is going to like basically kill you every time, right?
In an EFT, that's the penalty. I'm saying in an Amazon, it's just you just lost a sale. You lost an incremental sale. This is how to do, for people who join late, we're just arguing how to do profiling math, which is really easy to screw up, as Kirk just pointed out to me. and then you measure the wrong thing, or you think you've measured the right thing and you've measured something interesting, but you're reading it wrong.
Yeah. I think
Sorry. In the high frequency trading world, is there any sort of scale where you can spread the cost of profiling across many hosts? For example, on Amazon, they don't need to profile all the hosts all the time. They can just choose.
Right. And actually, you're running Java, you get profiling all the time, but it's at a 1% or less overhead rate. Whereas the EFT guys typically have a handful of trading. They have one access point to the exchange. And the question is, if a trade suddenly decides to go south, how fast can they unload? So that's the usual story. So they have one access point. Most of the trades, most of the time, move slowly up or down, and they're taking a delta increment by front running people. And so they get a very small margin, and there's a lot of other guys playing EFT, and they're fighting each other a little bit. So at any given transaction, they'll win or lose by 1%, and they do 100 transactions a second, each valued at $1,000, and they gain or lose 1%. But they're gaining by a tiny fraction of we're losing, and so over the course of the day they rack up some money. However, if a transaction suddenly stalls for like 3 or 4 seconds and the market's building around, they will be forced to unload that stock at a net large loss, and that'll wipe out the last hour's worth of gains. So they have the event that happens that's slow there costs them a lot. Whereas if they were quick about it, they would have unloaded it at the usual tiny delta before it sank below them far enough that they lost big. So it's not the case that they can sample off many different machines. They have one access point per exchange, basically. And you pay big bucks for that access point.
Is that really about the time to put the put on the table, or is that just about the time?
It's all about
or is that just like a take? I mean, like a take is different than a push, anyways, right? So
whichever way they're going, if they get out of the market money, their strategy is to never long-term hold at any cost, because that's where the market moves big on you, and you have to have a different strategy if you're going to hold long. So their strategy is always, we will unload this if it's a losing position. Now, if I'm 2 seconds out of the market and the market's moving fast, I'll unload it at whatever it takes to unload it at. And that can be all of it.
Yeah, so Kirk, he's talking about the front-running trades where you try to detect that someone else is trading. And so if they're buying, you rush in and buy and then turn around and sell for a penny more. So that's not the only kind of high frequency trading. It's just
that's
one
a low, right? I'm talking about low latency.
One.
Yeah, low latency trading. There's high frequency where you do a lot of trades, and there's low latency where you're interested in beating the other guy. So I guess I'm talking about low latency trading.
Yeah, but an offer is a different situation. Like if you're doing a put on the market, I mean that's a different situation than you're doing a take in terms of the race, right?
No. These are symmetric. It can be in both directions. They don't ever actually move the stock around, so that they'll run short positions just equivalently as running long positions, and then they'll sort it out.
They're trying to catch the wave in the smallest way possible,
right?
In the lowest risk way possible.
And the lowest risk rate possible. That's the main gain, is that nearly every transaction wins them a small amount of money, multiplied by 1,000 a second, and that's their.
Unless you get hit by a latency event, which means you get pretty much wiped out for the day.
You get wiped out. Well, yeah, it's not for the day, but it's 100 times to 10,000 times more expensive than the typical gain you're getting. So you lose many gains for every long latency event. Where long latency is not really microseconds, it's generally seconds. If you're microseconds, you lost, but you didn't lose big. You just didn't make any money on that transaction. If it's in seconds, you can lose big.
Yeah, but seconds doesn't require high sampling rates to detect.
No, but it requires. So it's you're looking for. So Zul's done this for a long time. You're looking to diagnose. So something happened, and you detected it because you got your pants beaten off you. So what do? What's the correct thing to have gathered to let you diagnose the situation? Right. That was the Azul issue for a long time. It took us a lot of engineering in the JVM to diagnose where the event came from, and then some large fraction of events below a certain threshold, a large fraction of events come from the OS and not from the JVM. Right. So there was a lot of OS tweaking going on. So the Azul feeds to the low latency trader guys, right? So there's a lot of OS tweaks on a standard Linux kernel to get it to behave well in a low latency scenario.
Right.
And some of them are just about diagnosing what happened. The kernel stepped in because you took a TLB miss on a Stack Overflow and decided to go zero a page. And so, your TLB miss got honored a millisecond later because it first 0 to 2 meg page out to hand off to the process or something like that.
Right. Huh.
I'm pretty remote to this world, so I'm curious what features of Java or hotspot in general hurts in that case. For example, the optimization gap, batch collection, and all these kind of things.
Well, so why are they using Java at all? So I've talked to like every HFT in Chicago and half of them in New York, and half of them wanted to know what the hell the guys using Java were doing, and the other half wanted to know how the hell to make Java have lower latency. and so the answer is like they love Java because they can flip algorithms faster.
Yeah.
And they hate Java because of all the mystery latency costs. And then there's some of them are well known. So there's, and Azul totally hammers on this all the time. So there's the startup costs. At the beginning of the trading J, if you've started a new JVM, it hasn't seen actual load, nothing's jitted. And so there's latency on the jitting. So you get hammered at the opening because, he's behind, he's running interpreted, and then he's taking, various kinds of funny pauses. And he's class loading, and that causes locks to be held. And the compilers are all busy and they grab the code cache to install code, and the deopt, it has to happen. You block the code cache again, and then you run an interpreter wants to go grab fresh jitted code, and the code cache is locked, and you have to wait for those locks to come done, blah, blah, blah. Round and round it goes. Okay, so fine. All this clears out in 10 minutes. But meanwhile, they're getting their pants beat. So they have all kinds of things like we throw fake load on before the start of the day. We don't trade real money at the opening, although there's a lot of money to be made in the opening and the close for the same reason. There's a lot of games going around where they try to ameliorate. What they really wanted to do was get high quality profiled code jitted before the start of the day. And so some of that's gone, the big push at Azul to collect stats and use them to jit code again without having to profile ahead of time. You still have the issue in Java that if you want to load jitted code, you have to load all the classes that went with it. You have to load the state of the heap that was visible at the time of the jitting, which includes all the class statics that have to be initted and set up before the JIT does what it does, because the compiler totally takes final statics and turns them into constants, and then constant folds. So those final statics had better be loaded as well. So you can't just load code, you have to load fucking heap. And so there's a giant pain in the neck to make that work. And so these guys are all about how do we fix this and make it better, and what do we do here? There's GC things. They all have a different story on GC. Half of them don't do a GC. This is now maybe, I'm talking maybe 10 years old. Half of them were not doing GCs. And half of them were tolerating the GC, but they had it as part of their strategy somehow. When I say not do GC, they would mostly do object pooling, and the GC was running, but it wouldn't take a full GC cycle throughout the course of the trading day. Or if it did, that was considered a bug. And then at the end of the trading day, you simply rebooted the JVM.
Sure.
The guys who were tolerating GC went in with slightly different strategies and setups. And, they could tolerate the occasional, long latency stall, long from their point of view stall, but they were maybe moving away from low latency trading to high frequency, and they just weren't trading now for a little while. And that was okay to lose a few seconds of trading on average every hour to a GC cycle.
Yeah, we've seen the all kinds of different strategies in terms of like peculiar configurations to try to avoid that. And yeah, so I think
giant ass heaps.
Peter Lowry, I think, is like the master of that realm. I've seen some of his configurations; they're quite nice, and you can learn from them.
Yeah. Who's the guy who does Disruptor? Martin Thompson. Martin Thompson's big in that space as well.
Yeah, just talking to him this morning.
Oh, nice.
Yeah, he doesn't do much GC tuning. He just does the let's not make garbage thing.
He does the not make garbage approach. Yep.
Yeah.
He likes writing C in Java.
Yes.
I do that all the time.
Yes.
I've done a lot of big data ML stuff, and there's a lot of C and Java I end up writing, and it works. It's not necessarily what the average Java programmer programs, but totally works.
It's kind of fun.
All right, somebody else. Some of these newcomers. So Tim Underwood, what are you doing for a living?
Oh, hi, Tim.
Doing mostly Scala development for a German company in the automotive aftermarket parts space. So really just writing web services, websites, stuff like that. Sometimes I like to take a deep dive into, performance work or messing around with trying to tune garbage collection or, doing object pooling to avoid garbage collection in the first place and stuff like that. So that's kind of that's why I'm here. That's kind of what I'm interested in.
So you're writing web services or doing things with automotive parts?
Pretty much web services. Yeah. I mean, we're right now I'm working on trying to handle, we have a bunch of VIN databases. So this is for the European market. We have, VIN databases that have, I don't know, millions and millions of VINs that tell us what parts they map to, what OE parts they map to. So customers can come in with their specific VIN and get back a list of, the very specific OE parts that fit their vehicle and, just how to efficiently load that data, how to efficiently search it, all that type of fun stuff.
See, somebody says go Scala.
Yeah, that's me. I used Java for like 15 years, and then Scala came out, and I heard about it from Dick Wall and Carl Quinn of the Java Posse while driving, commuting, and tried it out, and then did Scala pretty seriously for about 10 years. And since I'm a contractor, consultant, I have to do what people will pay to do, and I haven't found a Scala contract in several years, so only using it for hobby stuff.
Yeah, I've been doing Scala for probably about 10 years also.
Mm-hmm.
For a long time, it was, I had my own startup, and so it was kind of a personal choice to use Scala, and then that kind of transitioned into a partial acquisition, and Scala just kind of continued on. And so it's kind of been forced onto the rest of my team now. But I think in general, people enjoy it. I mean, there's pros and cons, but overall it's a pretty good experience.
Mm-hmm. I contracted at VMware for a while and was part of a group of people who got Scala adopted there for some very important projects.
Dave, you're a teacher too, aren't you?
Yes.
So you teach programming to kids, right?
I do, yeah.
What language do you teach in?
I recommend Python to start, and then to get them interested in kind of a motivating thing, we do P5.js, which is a JavaScript library for doing 2D and 3D graphics and animation. So
run in the browser, or is it a Node.js?
All runs in the browser.
Oh, no.
So,
okay.
And a lot of the work we do in Repl.it, which is just a free website that supports something like 20 different languages. So we can play around with Ruby or TypeScript or JavaScript or Java or Scala, or actually, I don't know if it has Scala, but usually Python and JavaScript we start with. And
So
right now I'm
has
teaching
anyone
a class
tried? Oh, go ahead. Sorry.
for the Athenian School in Danville, California. And we're doing Ruby programming with Sonic Pi. So we're making music and sound effects with Ruby programming. It's great fun. So a mix of things.
Nice.
So who has tried Kotlin?
I have a little bit.
And?
A guy I know who helps the robotics team, the first robotics thing, Dean Kamen, at the Athenian School has kind of introduced that to some of the team, and I volunteer there and help a little bit. So I've played with it, but haven't used it much. How about you?
Played a little.
Our development is in Kotlin.
Well, how do you like it?
It's amazing. We have like 50 developers already developing in Kotlin. In our company.
Can we get him to speak a little louder?
Yeah, we're having sound issues, Haim. This is like just quiet. Well, you muted. Okay.
Yeah, makes it quieter.
Say again. You have 50 developers doing Kotlin.
Yeah. Mm-hmm. Just a second. I'm trying to fix my. Oh,
Oh.
I know.
Or just shout.
Oh, wait, Haim, that's a fake background. I thought you actually had a computer behind you.
A big one.
Yeah, big one.
Well, they used to be much bigger.
So the Corona Zoom issues made me start using a theme of the 80s computers.
Yeah.
Switch one. That's a Synchro Spectrum, I guess.
Yeah,
Some
mine
of
was
your.
Trash 80. I had a Trash 80 in the 80s.
I had the Commodore 64, but.
There you
Go
go.
Commodore
There you
64.
go.
We
Yes,
used,
Spectrotech, yeah.
we used the Timex Sinclair, but the first thing you had to do was like strip them out of the box, right? And well, because we actually were deciding to attach them to sheep, so the boxes were convenient.
Mind-controlled sheep.
Yeah, sort of. Another story, I guess. Yeah, so I looked at one project and we actually converted it to Kotlin, and we got, nice way through it, and I just started asking them the question, why?
Okay.
And I don't know. I've never come up with a good answer to why Kotlin. And what are the advantages of using Kotlin? Is it going to give me any velocity wins or anything else in terms of expression? And I just looked at it and said, no, it just seems like someone screwed with Java and just said, okay, well, let's just flip things around here and make it slightly more Pascal looking like here. And I don't know, add a few other
Suppose
things.
if you're doing Android development as part of it, it makes more sense, right?
Why?
Google seems to be giving more help to Kotlin than Java these days.
Yeah, there's a lot of direct Kotlin support on the Google site, and there's a lot of mixed Java and Kotlin. All the examples are in both.
Hmm.
I did Android stuff last year.
Yeah, that would be a reason. But for regular stuff, I'm trying to figure out what the win would be.
Right.
I mean,
it's the same challenge every language on the JVM has, is that they have to do something significantly better than Java does it. And if you wait 12 years, the Java team will do it too. So it's like, oh, sorry.
12 years is long enough to do something about it now. But you're right. The Java has been playing catch up, and they have been playing catch up. And so they're catching up.
It's a mature language. It's good for them to play catch up.
Yeah,
We wouldn't want Java to be doing the lead, right? That would be awful. I mean, remember generics? Holy fuck.
They kind of messed that one up.
Oh, man.
Or I would have wished they had done something different. I think a lot of people wish they'd done something different.
I wonder if Java will ever have if expressions. That's one of the things I love about Scala, and I would guess Kotlin has if expressions too.
You mean trinary operator?
No, the fact that the if returns the if expression evaluates to a value that you could then assign to a variable.
It's like ternary.
Cliff likes terseness, so the ternary is going to be better.
Yeah, but I can use an if and else for the ternary, and then it's an expression. But I can't actually in Java. You're right. But I like terseness. But that's when I think if expressions, I think ternary operators.
That makes sense. Okay, let me give another example. Let's say you want to compute a value in a block of code, and in that block of code, delimited by braces, you create some local variables and do some computation, and then the last statement in that block is the result. Then you can assign the result of that block to a variable. So that's a more general example, I guess, of that kind of thing.
Yeah, no, I like doing that kind of stuff. And you're right, that's tougher to do in Java, or you do the obvious, syntactic sugar to blow it up and make it work.
I mean, Java can do anything that's functional as long as by function you mean class.
Yeah, there's that too.
Because your smallest unit of functional programming in Java is a class.
Yeah, anonymous inner class.
The class with one function that can be turned into a lambda, is that?
Yes, or what they call a method handle and things like that. It actually looks like it's a lot more work than just having done it the right way, but I'm sure they had good reasons. I mean,
They all came at it one step at a time, and no one wanted to break everything, and no one wanted to take the big bite, and so they kind of crept into it.
yeah, it's not horrible. It's just crufty.
It's just crafty as hell.
Well, and there was sort of like this drive towards making everything immutable that sort of got
That
him.
was, yeah, Brian Getz going, you know,
Yeah,
nuts on immutable, which was, you know, it's good up to a point. It does some cool stuff. There's some real limitations, but if you can make it fit with immutable saves your life in a lot of ways. So fine.
Yeah. Well, it's funny because like for a while, I don't know how it gets converted now, but the like copy on write array list in Java looks immutable, but if you look at the JIT code, it's not. It's really weird.
No, I get it. There's some performance thing.
I like the guideline for Scala programmers that you make everything. So there's val and var, and val is like a, you know, final int kind of thing, and var is mutable. The idea is you try to make everything with val, and if you find yourself needing to use a var, then think of a way to restructure the code so that that you can make it immutable. That's a challenge for somebody coming to Scala from Java, say.
Yeah.
So I drank the Kool-Aid or accepted the idea that things should be immutable, not completely understanding what the benefit was, and trying to explain it to other people. Like I could say things like, well, it reduces it makes it easier to reason about what the program is doing or the class is doing if you know that the instance variables aren't changing, or something like that.
Does it really?
Right.
Though?
It's easier to do code reviews because if I see a val, I know it's not going to be reassigned anywhere else. When I see a var, you know, I don't necessarily know, you know, is this being reassigned somewhere else later in the code?
And more generally, with Java code, the same thing applies to saying like final int. If you say final int, I know that that's not going to change later. Charlie's disagreeing. I personally do find value in knowing that something's not going to change down the line in a large block.
And I wasn't so much disagreeing with your point. I agree. I actually love that. I was just disagreeing with that you can't change a final variable later in Java.
Yeah.
Because you can, and everyone does it, and they cheat, and it breaks all kinds of things. But you can use reflection to do it. Don't do it.
Oh, okay.
But people do it all the time.
Yeah.
I mean, somebody else's to deal with somebody else's code.
The other thing is the whole thing with const, you know, going back to C, C++, et cetera, this idea that, you know, okay, let me see, I've got 4 consts in this type expression.
Yeah.
Which thing is changing and which thing can't change? Because like in Java, it can be final, but it's still a mutable object. So even if I don't change the reference, I can change what's inside the reference.
Right. Same problem. In arrays, you can't make the contents of arrays immutable.
So there's no deep equality. There's no deep immutability.
See, deep equality, I claim you have to add as a user mode thing. I would not ask the language, force it or make it happen, because that has asymptotic runtime costs that are interesting.
Yeah.
Whereas deep immutability, I would like to see show up. Like the whole enumerations, you want to go get an array of your enums and walk it. Well, you get a copy of the array because the array is not immutable. And if you ask for the original array to walk
Java,
it,
right.
yeah, talk about Java. No, but in general, in languages in general, I think deep immutability is a useful property to be able to specify. Deep equality, I think, should come out on a data structure by data structure basis and not be a language-wide property because it's easy to screw it up using it. Because deep equality means deep, and that means you're going to walk the guts of a structure, which can be cyclic and it can be huge. So I think you have to ask for that personally. I myself do a whole lot of stuff with hash consing tricks, where if I ever do a deep equality check, that's 100% fail. Not just slow, it'll just hang forever. So you know, I want to very much know that my equalities are pointer equals. And at the time I make a new object, I will intern it. That will do the deep check up to the shallow structure it needs to go intern. Once it's made, it's pointer equals only. And you know, that goes for everything in the systems I've been working on the last several years, including strings. And of course, every compiler on the planet complains about I'm using strings with equal equals, although I know damn well they're all interned and they better goddamn be interned or it's broken. So I have to go deal with telling Java, whatever, IDEs everywhere, leave my strings alone. Fine.
I found interesting when I was learning Scala that we were advised to use the immutable collections. So imagine you have like a map and you want to add things to it. So you make an immutable map initialized to some couple of key value pairs. And later you want to add to it. And what you do is you add to it in such a way that a whole new map is generated from it, but it reuses the portions of the previous map that are unchanged by the operation.
Yeah, they're called persistent data structures, and they're common in functional programming languages. I was actually going to ask if anyone had experience with those. What's your take?
Well, I just followed the advice and did it and just let it work that way. So without really understanding the benefits.
The general,
pardon?
The general cost is performance. The general benefit is functional behavior out of structures that otherwise look like they have side effects. So you get rid of another source of side effects.
Yeah, the performance isn't too bad because they use a 6-way tree, 32-bit. I remember looking at how they did it in Clojure. It's pretty. So basically, they only pay every 6 mutations. They only pay for a new structure every 6 mutations.
Well, fine. I do a lot of high performance work, and I'm fairly certain that overheads that I have seen and observed are like orders of magnitude bigger than what
of course. But I mean, they're still not as bad as you would expect when you hear that someone's creating a new data structure on every operation.
Yeah.
Yeah, I guess my typical pattern in Scala is, I mean, I have a lot of, lookup tables, hash tables that get built once at startup time and then just referenced from there on out. And my typical pattern will be to build it up as a mutable data structure and then convert it to an immutable data structure, or simply wrap it and make sure that there's no, mutations exposed. And then that immutable structure can be referenced everywhere in the code without paying any performance penalties.
Oh,
but knowing, with the guarantees of knowing that, I'm working with an immutable data structure now, everywhere in my code.
But you've known upfront the set of mutations you wanted to have.
Right. Yeah. It's all paid at startup time, and after that, it's a static. It's a static.
Right. So I'm typically dealing with structures that I don't know ahead of time, and so I have to keep incrementally adding, millions and millions of things, and I don't want to have the overheads that go with the immutable structure style of things.
Right.
Fine.
Tim, what made you decide to do that? Was it performance measurements? Was it expensive to?
I mean, really, that's just how the data that I work with is structured. I mean, I have a set of reference data that's pretty much static that, gets updated maybe weekly or even monthly. That just has stuff like, okay, here's all the various vehicle configurations for different markets, for the automotive parts, here's the different types of parts, here's the different types of criteria. And so it's all just stuff that's mostly static. And I really just need quick ways to look up that data. And so it just fits well to, read it once at startup time, build up all my structures, and then just reference those.
But I'm saying that when you're building it up, you're doing a bunch of inserts into some data structure. You decided to do that with a mutable collection.
Right.
And why was that? Why didn't you go with immutable?
Mostly because it's more performant.
Okay, that's what I was
It's also more performant to use some of the actual mutable hash tables as the underlying structure when I'm doing my lookups, and just wrap those to make it look like it's immutable, versus some of the actual immutable trees that Scala has.
I see.
What's the performance difference? What did you observe?
It was, I mean, it's significantly slower to build it up with the immutable data structures.
Okay.
I mean, it's much faster. For most of my collections, I'm using the fast util library. So I'm trying to use the primitive optimized collections where possible. And I end up just having some lightweight wrappers to provide the actual Scala like map interfaces over the top of those. And so it's faster to use those structures, which try to minimize memory allocations and all that stuff. And then just kind of put a dummy wrapper over the top, basically saying, okay, now this is immutable. There's no modifications allowed via the interface it's exposed. But I mean, of course, the underlying structure is still the mutable hash table or whatever it is.
Yeah, yeah. Makes sense.
I've also found that some of the open hashing algorithms work dramatically better than the linked overflow because of cache locality.
Right,
So,
and that's what most of the fast util stuff is. That's what I end up using. Yeah, they simply just have, you know, a couple arrays basically and avoid the whole linked list overflow. And it seems to provide a significant speed up over, say, the Java or the Scala built-in hash tables for the type of stuff that I'm doing.
yeah. Yep. And even those are pretty good. It's amazing how much they've optimized them, but yeah.
Right.
Take a look at the non-blocking hash map at some point.
Yeah.
Just curious to see if it does any better or worse than the fast collection.
The one you wrote at Azul, you mean?
Yeah, yeah, it's still out there. It's in
I remember that.
That was a nice implementation.
It's been, you know, measured by various Google teams as like the fastest one on the planet as a generic hash table.
Yeah.
And then of course it's multi-threaded concurrent safe, which is, you know, sort of added bonus, but maybe you don't care on that part.
Is this something that's open source?
Yeah. JC Utils. I think finally JC Tools ended up in JC Tools. Let me go grab the link here.
So
I still use it
you
daily.
made the fastest hash table, and I made the most expensive hash table.
There you go.
That's true. So yeah, I did some benchmarking of different hash tables and stuff like that, and like the one you wrote, Cliff, is the only one that can completely pin the CPU.
Yeah.
And do useful work while the CPU is pinned.
Oh yeah.
Yeah. So it's a really nice implementation.
I just moved to a new machine because I had to complete fail the old machine a couple weeks ago. I don't have it on my desktop lying around here, but I have of course, Windows is not being helpful here. Here we go. I have it on the old hard drive. It's just stuck off to the corner here. Let me pull it up.
Isn't that funny? The main reason we need bigger hard drives in every generation of computers is so we can zip up our old hard drive and drop it in some corner. I have somewhere on my computer my old hard drive, and inside that is the old hard drive before that. And I swear it must go 10 deep at this point.
Oh dear. No, I'm only 2 deep. There we go. JC Tools. Buried in the bottom of JC Tools is the current non-blocking hash map implementation. That's where I've kept it. And like I said, I use this on a daily basis because it's as fast as the fastest single-threaded hash table, and it's multi-threaded safe, which sometimes I care about, and sometimes I don't. And it's also fairly low memory consumption relative to the open linked list guys. But I didn't try that hard. I tried for performance. So the fast tools might, performance is speed. Memory footprint is speed in some cases. So you get small enough form factor, even if it's more complicated, you still win because of caching effects.
Yeah.
So H2O, big data, ML speed was all about compressing and winning on bandwidth, generally by integer factor speedups. So, a few million things, you're talking a few million VINs plus all their parts, that would be chump change to H2O.
Cool. Yeah, I'll take a look at the JC Tools thing.
Yeah. Drop-in replacement for hash table.
There's a few bits of weird code in there that don't quite make sense, but
you're talking about what piece are you talking about? You're talking about the actual implementation?
Yeah, the actual implementation.
Oh, gosh.
Like you waste the zero element with some control bits and things like that.
Yeah, right.
Yeah.
Yes, that has to be there. Welcome to the land of concurrent, thread safe concurrent programming. It's immutable. That's part of the immutable hack for concurrent thread safe shit. There's a one-step installation of the next generation hash table when you have to resize. And you can only do that once, and you can never undo, and because all threads have to agree on what happened. And so that's the 0 element getting migrated to the next level of thing. There is a couple of hacks to do to avoid pointer directions where the 0 element carries the metadata, so I cannot have another top level structure to bounce through. It's nice to not bounce through another pointer to get at the underlying array and the like, but in fact, I cannot because it's not thread safe, because somebody else will install the upgraded size. The race is on. Once the upgraded size race is determined and somebody's putting it in, there can be only one winner. And that's what is locked into slot 0. That was very exciting on your camera, by the way.
I'm sure it was. I'm just trying to find my phone. I'm getting random calls from people claiming to be from the Canadian tax authorities saying that I need to call them and give them lots of money, I guess.
Kirk, you and I must have been like breaking the same laws. I got like 5 of those calls today.
Already?
Yeah.
Canadian tax authority?
Windows tech support.
But the Canadian government is really cool now. They take Bitcoin. If you're willing to pay them in Bitcoin, they'll take, no, that's just the scam. The scam is like, and the government wants you to pay in Bitcoin so that you don't go to jail. It's like, I'm pretty sure no government anywhere is taking Bitcoin right now.
These days, my spam calls all are in Chinese. And eventually I looked it up, and it's like somebody who's trying to do, insurance scam, some kind of scam for immigrants, Chinese speaking only immigrants. So they tell you you've broken the immigration laws, which probably if you only speak Chinese, you have, and that you have to go talk to them, and and they'll set things right. But it's entirely a scam. So, phone rings, you pick it up. It's a different phone number every time, all over the U.S. Pick the phone up. The Chinese, they rattle off right away. It's like, okay, this one's not intended for me. I hadn't heard Bitcoin from Canada. Canada's pretty cool, but Bitcoin's getting a little stretched there.
So has anyone used Erlang?
Not in forever and a day. Long time ago.
No one's speaking up, huh?
No one's speaking up. It has a very interesting programming model, which kind of actors took over.
Yeah.
Has a central shared repository, and I'm trying to get all other weird things, and actors, and then a lot of performance hacks you do around immutable and actors. And the mutable part is the central shared repository. It's a classic database thing.
Has anyone done anything with fibers? I know we talked a little bit about that.
Java, I've done a whole lot.
Not Java, no, fibers.
I'm sorry, what is fibers? I thought you were talking about fibers in the Java.
No, I guess they are introducing some
The loom guys, they have a name for it, and fibers is what they're using. We talked this last week. The Loom guys talked real big last week. They aren't here right now.
Yeah, you're talking about Project Loom, right?
No. Cameron's talking about fibers, and I don't think he's talking about Loom. So now I'm trying to figure out what are you talking about.
Yeah, I thought Loom was about continuations more than anything.
No, fibers.
Fibers.
They're claiming they're going to make the thread spec API, but not use threads. And under the hood, they're calling it fibers, but they're going to match the thread spec, except for a handful. Like they really think they can get really close to the thread spec and have fibers like performance, like have millions and millions of threads, where the Java thread thing is a 1,000,000-to-1 ratio to an OS thread. I've done a lot of shit with fork join and fork join tasks, which are kind of sort of like fibers laid bare in plain old Java code.
Yeah, we're doing fibers for our runtime, so I was curious if who else had experience with it.
Yeah, I don't know. I was just trying to get the concept. I mean, do you remember like LWPs and like Solaris?
Yeah, yeah.
And you know, one of the things we always do with LWPs and Solaris is like turn them off.
Okay.
Right.
When they came out, I think we even used them for a while. And then
Yeah.
went back to OS threads. Green threads, like Java had green threads for a while.
Yeah, it's like, you know, and where did they go? You know, so
Well, they got turned off because they didn't have enough support from the OS.
right. And you start looking at these like different implementations coming out, and I'm just trying to figure out, okay, you know, we're going to put something over a thread. How is that going to be better?
Because
I mean,
the cost of a thread is too great. You could argue that an OS abstraction for a thread is the incorrect abstraction, but it's the common one, and the cost is too high. So the common cost model for a thread is I burn 1 to 2 megabytes immediately of memory, and every time you do a blocking call, such as a TCP socket waiting for a web server, the thread is burned, including its 1 meg overhead. Now, if I have a million of these things running and they cost me a megabyte a pop, I'm burning some real memory. So there's an overhead there. There are more overheads than that. And the OS has large counts of data structures are using to track these things, because an OS will do perfect storage reclamation of all resources when threads die, whereas people, Java folks, screw it up all the time and count on GC.
Okay, so the question is, how are fibers going to change that?
So the goal of fibers is that the cost for a thing that Java claims is a thread drops to a kilobyte or even hundreds of bytes. So there's several orders of magnitude memory reduction, yet it behaves like a thread in thread-like context. So if you make a blocking call, the loom guys intercept the blocking call, block something else with a callback, basically get a callback from the OS. So Java has intercepted all calls to the OS. So the loom guys intercept all calls to the OS and make all blocking calls do a callback when the thing returns. So that fiber is put on a callback list, and different fiber shows up and runs on the OS thread.
Okay, but the real cost in this is really the context switch, right?
No. There's multiple costs. The context switch is one of them, and you're going to pay a context switch cost. It's cheaper at the OS level, or at the user level, it's cheaper to the context switch. It is still not the majority cost, though. The majority cost is losing access to the megabyte or 2 megs of memory that the thread represents.
Yeah, and it's actually much worse than that, because if you do anything, say with reactive style programming or anything like that, what happens is you're coding, you call in to something else, so your stack isn't just lost, the 2 megabytes that Cliff's talking about, it's actually trapped under some other execution. You cannot get to any of that until this returns. And this thing calls some system thing that turns around and handles some other actor. So you're desperately down here needing to do your work, but you're trapped until this actor finishes. Oh wait, it does an operating system call, you're fucked. You need more threads, right? So no reentrancy with actors. It's like taking the worst of JavaScript promise unwinding and Windows
to have asynchronous callbacks for reactive programming that do not share on the current OS thread, which then does spawn huge counts of threads and have a lot of context switch overheads. Yeah.
Right. So a giant benefit of fibers is that each logical thread of execution gets its own thread. It's called a fiber.
Logical thread, right. But when that logical thread blocks, the OS thread is available, but also you're saying the logical thread is independent of whatever else the OS thread is doing.
Right. So even if the logical thread wanted something else to happen, as long as that wasn't part of the same fiber, the logical thread could continue while that other thing is happening. And that's the reason we use it.
That's coroutines, more or less.
Yeah.
Yes, coroutines are built on fibers, exactly, or vice versa.
Fork join, you would just fork there. And then it was the case when I'm doing fork join H2O that you had to deal with the call, the blocking guy and the callbacks that came out of order.
Yeah, so we just don't have any blocking calls.
Yeah. Well, this is at pure Java, so you had blocking calls. The Loom guys are intercepting all the blocking calls.
Do you know if the Loom,
H2O, I had to deal with blocking calls manually.
do you know if the Loom guy are going to do anything with IO Uring on Linux? Because it seems to be quite
Doing
an improve with IO Uring on Linux. So it's this new queue for syscalls in a way
Right.
that you can do between user space and kernel space, and that you never really have to do a kernel transition, and you never really have to block them.
Can you spell the thing you were talking about? Because I couldn't quite tell.
Put it in chat,
It's,
sir.
yeah, it's IO_U, like for user, I think ring.
Yeah.
Put it in chat.
I just pasted one of the Project Loom updates from May, and it does talk about IO Uring being something they want to use for Linux.
I think they're reaching a point where they don't care, and then they can add it in as an optimization. First, they're going to run on Windows and Mac and probably Linux with standard stuff, but they're going to open the door for running that as an optimization down the road.
So it's interesting because they only talk about it in the context of asynchronous file IO, but this Linux feature is available for any syscall in a way. It's not specific to IO. You can do it for, like, you can queue any syscall basically. So that's what makes it pretty powerful.
Back on the memory thing for just 1 second. I'm just curious from like other people's experience. So I know the idea here is you don't have your 1 or 2 meg thread stack with your OS thread that you basically is wasted memory when you are running another thread. So with Project Loom, when your fiber hits a blocking call or something, they're clearly going to have to copy all of your currently used thread stack to another location.
They talked about it last time, yeah. They're literally doing a mem copy. What's the depth on a lot of these applications? How far into their 1 meg thread stack? I assume they're a couple of K. I don't think they're anywhere close to a megabyte or anything, but do you have any sort of guess on like the average, I don't even know what I mean by average workload, but like what's the thread stack depth of like a regular Java program? I looked at this shit at Azul for doing stack allocation stuff, and the answer was you went 20 to 50 deep, but there was a very shallow end where you did 95% of your work. That was only like 5 deep or something stupid, right? You preloaded in a shit ton, and then you did a bunch of work at a very shallow, and occasionally you moved the shit ton, but then you did most of your work at a very shallow depth.
Yeah, I mean, if you look at stack traces for running applications, they're quite often now in the 200 range in terms of depth, but that's a lot of it's inlined anyway, so it's not real 200. It's 200 in the stack trace, so it's probably 50 or 80.
I think for what Loom would need to copy stacks, you're only excited about what has changed since.
And it doesn't copy the whole stack either.
Right, that's what I'm saying. What has changed since the last time you did a blocking call? And the answer is probably not much.
They do some trick where they assume that you're only going to return like 5 levels, and then they put a guard in. So when they restore the stack to continue the fiber, if I remember correctly, they put a guard in and they only copy like 5 stack frames. And then, and if it returns to that point, they have a way of reloading the rest of it or something.
They take a trap and they go reload more. Yeah.
Okay.
I did similar like things for Stack Overflow where I just looked for certain depth transitions and then stopped and did something because you got exciting. And most folks, 5 would be fine.
That was my expectation, that you would only be really modifying 4 or 5, at most 10 depth in your actual. What's changing all the time? Okay, so that's cool. All right, so it is like, that's going to be like a huge memory savings for sure when you start talking thousands of things.
You're going to eat the memory for the whole depth of the stack. You're going to copy on and off this tiny little fraction, which represents 5 frames. So if your Loom thread went 200 frames in, you're going to eat the stack depth for the 200 frames. And if you have
Okay.
a million Loom threads and they're eating 200 frames a pop, you're going to burn that memory. That's not changing. So that's still down from burning, a couple of megabytes a pop for the million threads, but it's not non-zero. But the delta can be tiny, and that makes it performant to flop a new thread on or off.
And the other benefit with fibers is that you get much more management control over them.
Yeah.
So if you're talking about, I'm deploying to a server, it's my server, I own the server, you don't really care what your threads are doing, if they're using too much CPU, there's no such thing. But if you're deploying into a shared environment, or if you're deploying, onto someone's phone or whatever, you want a little more control over what resources you're wasting. So, being able to manage that, and control the life cycle control the life cycle of parts of the application, things you can't do with threads, like kill. There's a lot more you can do with fibers.
I actually have yet to see a credible benchmark saying that there's actually any performance benefits for using fibers at all. Maybe there might be a resource benefit, but there certainly hasn't been any.
Well, there's absolutely no performance benchmarks that show reasons to use threads. I mean, you'd be far better just writing code one thread of execution per physical core of the processor, and just be done with it. So threads slow you down. Guaranteed, it slows you down. I think it's about 0.5% on Windows last time I tested it. But I mean, the fibers are going to slow you down again. I mean, there's no possible way that you add abstraction and it speeds you up. So if you're looking just for raw performance numbers, you're not going to use an OS and you're not going to use threads, that's for sure.
Every problem in computer science can be solved with another layer of indirection, and every performance problem can be solved by removing a layer of indirection.
Well, and to finish my comment was saying, like, it does seem like it's gonna, the benefits are really gonna be offered by just supporting better programming models for asynchronous programming.
That's not just asynchronous, but just a better programming model. Yeah.
And that's why we're doing it, is because we couldn't do what we wanted without fibers. I mean, if we had to do it with threads, it would, well, I mean, we know what that looks like. It was done 25 years ago. Looks pretty good 25 years ago.
Are you using fibers on Java or fibers on something else today?
We're prototyping it on the JVM, not using Java fibers. So we're designing it for native code production, but
So your goal isn't to be on a JVM, I thought.
no, not at all. It's just a proof of concept.
Okay. So you're making a fiber-like thing for your language that's using Java threads, but I guess it's doing something smart with them. That's how you.
It's not even doing something smart. I mean, it's literally part of the state of an interpreter. The interpreter is a proof of concept for a language. It's not designed to be interpreted, so it's a pain in the ass. Like Java was actually designed to be interpreted, so it's incredibly easy to interpret it, and and it was not designed for native execution. So
yeah.
But for example, with
it was not designed to be JITted. That was the pain in the neck.
Yeah.
Well, they did have that compiler interface in Java 102, so
never went anywhere.
That's all you needed. No, but you mentioned asynchronous. So the thing is, if you have an asynchronous call, so you have a caller and a callee. In our design, that point between the caller and the callee actually creates a new fiber. Now, most of the time, it's a zero-cost creation because it's just flipping a bit. It's not actually creating a new fiber, because unless there's some work, unless you have contention unless you either have additional hardware resources that you can take advantage of so they could run independently, or you have contention on the domain that the first fiber was in, it actually just switches over and runs as a second fiber, and then when it returns, it goes back to being the first fiber. So it's kind of asynchronous by flipping a bit.
Yeah, fork joined to something almost exactly identical.
But the benefit is, if something does happen, someone else can come in and pretend to be this fiber, unhook the two of them.
Yeah.
So you copy on write, if you will, for the fiber. So now you have two independently running fibers, and when the second one returns, it actually returns a future. Right? Well, it fills in a future, I should say. The future already theoretically exists.
Yeah.
So the benefit of that, Kirk, is that first fiber is not held up, right? It can continue later, as if so. In what Cliff was saying earlier, you could have, many millions of these fibers, and that's something that you could not do with threads.
Yep. Well, H2O, I run millions, there's a sort of, I'm gonna say lower bound, millions to billions of fork join tasks, but I didn't have the language support, or the compiler support, so there was a whole lot of boilerplate you had to hand manage, and if you screwed that up, of course, things would just die like a pig. But when it worked, fucking works great.
A good use case I see is Akka with the agents, where you can have millions of agents all running independently and you don't have to do anything remotely asynchronous from the user code base, but you get all the advantages of everything runs in parallel without thinking about it. And even coming from the .NET world, I like this approach better from the user perspective than the async await, but that is...
Yeah, agreed. I mean, async await is a reasonable model when you want it. It's just, it only has two problems, which are the keywords async and await.
It's sort of like, what is it? Async or wait,
Oh yeah, well, there's the whole name issue. I always
bipolar.
bugs me on that one too.
I mean, it's not just the keywords; it's also the whole. You didn't, except if you are very mindful about it, you never really know where it runs, and you never really know whether it's going to block or not. And if it blocks, then it's very easy to lock yourself into a deadlock. So it's can get complicated.
Well, the fork join model, so I'm not claiming it's a good programming model, but the fork join concurrency model didn't deadlock you easily, or was difficult, because it was always, for every fork, there had to be a join. And then everything ran in parallel up to that point. The implementation, if you screwed up anything, was easy to deadlock on. I was running fork join on a cluster, and you would have cross-cluster calls with forking cross-clusters and joining cross-clusters, and that was easy to get into weird deadlocks. I claim a mental model that was similar, but with like language level support would be like a really, really good way to go. Or at least I'd be willing to try it and see how it works. Something where it didn't deadlock if you screwed one or the other thing up. I remember async and await giving me issues, not just on deadlock, but on when, who called back what for why. And I think fork join didn't have that problem. Different problems, but not that one. So I'm curious to see how your fibers go, Cameron. Sounds like a good approach.
So far, we're loving it.
I'm waiting to see how anything goes, actually.
Yeah. I've been pounding away on my language for a long time. I still have no implementation, so I can't do anything with it for real other than type. But I'm making progress, so maybe at some point I'll have a language here that people can go play with.
Is the name still AA, Cliff?
Absolutely.
Perfect.
At this point, you have to give me credible reason to change the name, or it's going to be AA.
I won't even attempt. I like AA.
See, there you go. So I'm staring now at loops and loop definitions. You have these, let's go back to small talk. And I'm like, I can do all loops with functions and tail recursive optimization in the typing system, Twitch. And so my loops look a whole lot like 4 C loops with a little bit different paren layout, except they're all obviously functions with, you know, different kinds of early exit for continue and break. And that's and the 4 keyword isn't a keyword, it's a normal, plain old ordinary variable that's been assigned a funny function, which takes functions and returns functions and tail calls itself. But it's an ordinary user variable. So I don't know if it's the right answer or not, but it's been kind of a fun way to review how loops work and why this C model is so widespreadly, you know, loved or something. People write C-looking loops like for a bazillion years and love them. And then there's separately, I'm not talking about, you know, Python, we would call it array, what the hell is the right word here? You know, do bulk operators.
Iterator or?
Yeah, iterators is what they are. There's another word for it. You understand where's the damn keywords? This is my senior moment happening again. Fine.
Sequentiality or something, or?
Yeah, but it's not functionality or continuationality or something. There's interpretation is in there, but it just means I have a for over a collection and I return you back a collection where I run a map on every element of the collection, plus or minus filtering, plus or minus whatever, plus or minus a reduction and a map. And that kind of model I totally support sort of casually because that's a purely functional model. But I want to have a for loop that's a while loop that you do random crap in your while loop. So you have to have something that looks sort of easy, lightweight syntax, but has arbitrary breaking conditions and arbitrary looping conditions and the like. Let's see, oh, this is your XTC is your stuff, right? XTC Lang, there it is, Cameron. It's in the chat. Go poke at this one.
That's me.
Okay.
No, it's a long enough read. You don't want to do it right now.
Oh, I see. Well, you have good comments. So that's a key one. I have people complain about me writing terse code, but I write a crap ton of comments.
Yeah, that's
all. Comments should be big.
Yeah, you should never have a question when you come back to your own code. Either the code has to be really freaking obvious, or there should be a book.
There should be something, yes, something there to help you understand what the hell you were doing. Why was I doing this again? Wow. Well, okay, so we're at a quiet moment. It's been an hour. We have any other? I have had requests for Asia time zone. So there is a Twitter poll up. Go bang on the poll if you have a preference. I won't switch over to an Asia time zone instantly in any case, but I might switch times from morning to evening, or I might do both for a while and see if we get any takers on the Asia time zone. So if you have an opinion, bang on the poll. If that's it, I think I'm gonna declare victory and hope to see people next week.
I definitely missed Matt and his links today.
Yeah. Well, there's a fair number of links in here. So the Loom link was good, but we had one last week. But I hadn't seen the IO ring one before, although I'd heard about it, I hadn't seen it. So I need to go back and I'll go stare at IO rings, and I'll go read your essay on containers. And you're using .x, I see.
Yeah.
Mentions instead of .aa. So not .xtc.
XTC is the XVM translated code, so that's the compiled form.
Got it. Okay. All right.
So I was just poking at Heinz, trying to see if you can get him into the channel, but apparently at this time he tends to sit at his pool, so.
He's got a rough life, so I can't, no sympathies. Now, not that my life's any worse, but what the hell?
Yeah, exactly. Say so.
All right, I gotta jump off.
Life is easy. Yeah, that's true.
Yeah.
Fine.
Same here.
You guys.
All right. Good night.
Cheers.
Thanks. Bye.
Good afternoon. Thanks.